questions, or we can good to move ahead. No, no questions so far. We are clear on what we have learned so far. याद रखना आपका टेस्ट भी है, थियरी टेस्ट है, कभी बोलना मत मुझे कि ये नहीं मुझे समझ में आया. Anyways, if you want to park your question, you can park. Maybe end of the session, you can ask me in case. See, I want this to be very transparent, and the interaction should be both sides. If you do not talk, you do not tell what is not. So I will not able to understand whether you are really understanding or not understanding. Okay. So keep this interaction open, and in case you feel something which is not clear or you need any options, you can always write on the WhatsApp also. You can write in a group. You can write one-to-one to me also. I will give you more details or more information as required for particular topic or a point or thing what is there. Okay. So let's start with fixed wing operations and aerodynamics. Okay. So as we know, there are three types or three categories of our UAV. So first is fixed wing, that is aeroplane. Okay. So what are fixed wing drones? Fixed wing drones are nothing but airplanes which generate lift under the wing due to the forwards airspeed which is produced by either an internal combustion engine or electric motor mounted with propeller. So it is like a aeroplane only. Okay, fixed wing drones are nothing but they are aeroplanes only or airplanes only. They generate the lift under the wing due to the forward airspeed which is produced by. So how this forward airspeed is been produced? By motion of your propeller. There are the two types of engines. One is the combustion engine, okay, normal your petrol engine, diesel engine, gasoline engine, or maybe a electric motor. So you have this type of engines. Small engines are available also, where you can put it on your aero modeling aeroplanes or airplanes also, or you can use your BLDC motor also. Okay. Now these aeroplanes needs to be mounted or handheld catapult or runway to take off and can fly continuously over long distance as opposed to hovering. So fixed wings are never stationary. They are always in a forward motions. They are always move into the forward directions. So that is what is the one of the disadvantage. But because of their forward motion, they can cover longer distance. Okay, they can cover longer distance. So types of fixed wing drones based on the wing type. So first type is straight wing. Straight wing, you can see straight wings. These are all straight wings, but there are little bit change in the structure. So rectangular straight wing, which are very less efficient. These are not used anytime in now aeroplanes. Then you have a tapered straight wing, so you have better efficiency compared to the less efficient or the straight wings. Whereas highly efficient are the rounded or elliptical straight wings. Have you seen any aeroplane with this type of wings? Can you give an example? Anybody has seen where this type of wings was used?
Mostly in gliders.
Gliders, yes. Anywhere, airplanes,
Trainer plane.
trainee airplanes, small airplanes, you will see something like this. But if you see World War II aeroplanes,
Yes.
Spitfire or Mustang, those were actually, because their shape, their aeroplane was small. They were only for two people, one or two people. Aeroplane was small, so they were able to create this type of rounded or elliptical straight wings. Even if you see their vertical stabilizers, horizontal stabilizers are like this shape, right? That is called round or elliptical straight wings. But in a bigger aeroplanes where we need more surface area, okay, क्या प्रॉब्लम है मालूम? ये विंग्स का पॉइंट है ना, वो टेपर्ड है, तो यहाँ पे वोर्टेक्स क्रिएट होने की ज्यादा चांसेस रहते हैं. So this is not also good design compared to other designs. Okay. Now there is something called swift wing. These are the aeroplanes which normally used slightly shift wing, moderately shift wing, or highly shift wing. So depending upon the shape, it will give the efficiency in flying. So these are being created for different purposes. Okay, for different purpose, different models, different type of size. So this shape of the wing is based on the overall design of the aircraft. Every type of wing will have its positiveness and negativeness. Okay, so we have to see which is appropriate for that particular aeroplane or that particular size of the aeroplane and the purpose of the aeroplane, what is we are intent to use it. Okay, so based on that, we will use these designs. Okay. The third one is the delta. Delta is simple delta wing. This is simple triangular is simple delta wing, or a complex delta wing. You can see it here. These are basically used for high speed subsonic or supersonic flights. Very high speed. The aeroplane flying at a speed of 2x times the sound, or maybe three times the sound when it is flying. The supersonic type of flights. That time you will have this delta wings. Okay, so you will see again. See, these are not a aeroplane with a common wings. Okay, normally your commercial aeroplanes are very straight. They have little bit angle, so they will be combination of swift wing. Okay, something like this. Okay, then there are little bit. So I mean, you will take the best part of all the three types. Okay, so all the best part of the three things are being taken and designed. So like if you see the elevators, okay, they will be designed something like a delta wing, small. So they are basically control surfaces. So combination of all these three types will be used in a civil airlines or commercial airlines, okay, based on the requirements. So that's where the aeronautical engineers will design the aeroplane in that way. Okay. So let's see now what are the parts of the fixed wing UAE. So as we said, the fixed wing UAE is similar to your aeroplane. So it has a fuselage, okay, a larger or the bigger structure, aerodynamically designed. It will have a horizontal wings, which has the ailerons, which converts the roll motion or controls the roll motion of the aeroplane or the fixed wing. Then you have a horizontal and vertical stabilizer. Your horizontal stabilizer, where it will control your control mechanism, is elevators will control your pitch motions, pitch up, pitch down, whereas your yaw motion is controlled by the vertical stabilizer, that is called radar. Okay, so it will have a radar which will motion change the heading of your fixed wing. Then you have engines mounted on the wings. Okay, if engine could be gasoline engine or combustion engine kind would be, or it could be a motor also, electric motor also. Okay, but in normally in a bigger fixed wing, it is always a combustion engine, because we need to have a more capacity to weight to ratio, and it has to have a more endurance capacity. So those things is required for a fixed wing to work or to bring into the operation. One is the capacity for a higher payloads, and second is longer duration to fly. Okay, so in that scenario we'll normally always use in a fixed wing is internal combustions. हम लोग इलेक्ट्रिक मोटर कहाँ पे यूज करते हैं? जब हम लोग वो यही टाइप का फिक्स्ड विंग यूएई फॉर ओनली रिकर्शनल एक्टिविटीज के लिए, जैसे हम लोग एरो मॉडलिंग में करते हैं. एरो मॉडलिंग में हमें कोई बड़ा बड़ा पेलोड पिकअप नहीं करना है, वी जस्ट फ्लाइंग फॉर फन. So that's a very lightweight, hardly 1 kg to 1.5 kg or max 2 kg का weight होगा आपका aero modeling aircraft का. So there you can use electric motors and you can fly those aeroplanes. But the bigger fixed wing aeroplanes, okay, or fixed wing UAVs, which are used by defense, which are used by weather departments, or for by military purposes for reconnaissance, या फिर surveillance activity and kind of things, okay, or even for example like agriculture, like last year in Gujarat, the complete Gujarat district was surveyed using the fixed wing UAE for monitoring the crop. So they wanted a complete crop map of the Gujarat area. So they have set up a one big team which is actually going to use the data from this aircraft as well as from drones of the Gujarat region to monitor the performance of the crop. So they are doing crop monitoring and giving suggestions to farmers on how the crop is getting developed or what is required or what is affecting their crop yield and all that thing. So there is a separate team has been formed by Gujarat government, which helps the farmers to get the real time data of their crops. So initially they have flown a fixed wing UAE to capture the entire Gujarat state details about the crop and the land and crop region, vegetation, where there is a water bodies available, where there are mountains available, where are the people, I mean, the villages or the cities are there. So they wanted that complete map of the state in real time. So they will be flying such kind of fixed wing UAE every 3 months, and they would be capturing that data, okay, regularly. And on a smaller basis they will be flying a rotorcraft drones for a smaller regions of area to capture a different type set of data. And see, this all data will be analyzed and will be available for farmer to know the status of their farms and the crops. Clear? Then it will have, the fixed wing will also have the landing gears, because it needs to run on the runway and land on the runway itself. Okay. So any questions on the parts of the fixed wing?
No.
Now let's see what are the components of the fixed wing. We have seen only the parts. Let's see what are propulsion system, fuel system, control system, avionics, how takeoff and landing will happen, and what kind of payloads will the fixed wing will be having. Okay, so propulsion system, you have two types. One is brushless direct current motor, that is BLDC motor, what we call. It's a electric motor. And then second propulsion system is IC engine. Now both the motors would require a propeller. Okay, propeller which basically converts your angular motion into the forward motions. Okay, so here brushless motor is high power to weight ratio, available in wide range starting from 5 grams. So these are very lightweight, smaller motors. Okay, these are best suited for nano micro categories or micro categories of, not category, I would say class of drones or aeroplanes. They are low noise, help in keeping low profile in stealth operations. That means they can fly low, they can fly quietly, smoothly, and all the things. Whereas if you see IC engines, they are very noiser. The engine voice noise will come because it's like a bike or like bullet firing. That kind of engine it is. So you can hear it from very far. Okay, conventionally used, they are higher endurance than BLDC because of the fuel capacity. It can fly for a longer period, maybe for 2 hours, 6 hours, 8 hours, 10 hours. The more the fuel you provide, it can keep on flying, keep on flying, keep on. Here your battery is limited. In BLDC your battery is limited, so you can get here maximum flight time of 20 minutes, 30 minutes, 40 minutes, or max to max 60 minutes, not more than that, because the more power you require to provide, the more battery capacity you need to provide. So the more battery capacity you try to provide, it will become more heavier. More heavier, that means the aeroplane has to counter the weight ratio, to higher power. So that means again it will need more power. So you can't have endless power in BLDC as of now. Okay, because your batteries are very very heavy component. As of now, in the drones or in the rotorcraft, the maximum weight is being capped, is being taken by the batteries. Okay, so battery takes the maximum weight of your drone. Okay, almost 50% of weight, more than 50% of weight in some drones is being taken by the battery. The more battery you add, the more heavier your drone becomes, at a cost of very, we do not get much efficiency in the flight time by adding bus simply additional batteries. Okay, but whereas in IC engine, it's just a fuel tank. Okay, instead of 10 liter I can put 20 liter, but 20 liter will give me much better flight time compared to whatever I add up battery twice in BLDC flight. Now to power the, to convert the motion, angular motion into the forward motion is done by propeller. So if you see, propeller is designed with respect to the Bernoulli principle. Can you identify the propeller shape over here as per the Bernoulli principle? Are you able to identify? So the Bernoulli principle, as per the Bernoulli principle, the airfoil design of the propeller will always have the leading edge and the trailing edge. So the thicker edge is your leading edge, the thinner edge or the edge where it joins the upper surface and the lower surface is called the trailing edge, which is always a thinner. Okay. So looking at this propeller, you should able to tell which type of propeller is there. So there are two types of propeller. One is clockwise and another is counterclockwise. Okay. Are you aware that there are two types of propeller, clockwise and counterclockwise? Or do you think that propellers are all same?
परत सांगा.
So there are two types of propellers. One is clockwise and one is anti-clockwise. So looking at the propeller, can you identify what type of propeller is this, whether it is a clockwise or anti-clockwise?
ड्रोनचे जो फ्रंट साईड असतो ना, ते फर्स्ट मोटर आहे ना, ती क्लॉकवाईज फिरतं,
Okay.
म्हणजे बाहेरून फिरते. आणि काउंटर क्लॉकवाईज असते ना, ती पण बाहेरून फिरते. म्हणजे त्याचा थ्रस्ट म्हणजे खाली जायला पाहिजे.
Okay.
म्हणजे पहिला CW प्रॉपेलर येईल, त्याच्यानंतर CCW, त्याच्यानंतर परत CW आणि 4 मोटर ती CCW.
Okay. So partially you are right, but probably you may not be able to articulate. So when we do the practicals on a third day, when we enter into the store, when we'll be taking our drone out, I will talk about this in more detail to make you identify the propellers. Okay, the counterclockwise and clockwise. Basically, you need to identify the leading edge and the trailing edge. That's why I told you that airfoil design is more important to identify or to understand. So when you are looking at the airfoil design, looking at the propeller, you should able to tell which is the leading edge and the trailing edge of the propeller. And based on the propeller, you will able to identify the type of the propeller, whether it is a clockwise or anti-clockwise. And then when looking at the drones, either quadcopter or hexacopter, you should know where what propeller is attached, whether it is a clockwise propeller or whether it is an anti-clockwise propeller or counterclockwise propellers. Okay, so I'll as of now I'll park that topic over here because I need to physically show you the differences. I want to make you understand that. So I will do it on the day 3. Okay, so connected, the propellers are connected to the BLDC or engines, providing thrust by rotating in size in a particular direction. The propellers, more or less, they are made of wood or industrial or small grade plastic, or also made of carbon fiber. So you will see, when we go to our resort, I will show you there are some very large propellers like this. Okay, big large wooden propellers which are being taken from the vintage aircraft. Yeah, being into the aviation for last almost 90 years, 90 plus years, we have lot of access to the old parts of the aeroplanes. So we have lot of vintage aircrafts. We have lot of parts of vintage aircraft and all the thing. Even the aircraft which was flown by JRD Tata in 1928, it was there with us. It was lying. It was condition very depleted. Our student of aviation couple of years back, they restored it back to the what we call it a normal functioning level. So now that even that airport, that airplane is in a flying condition as of now. Okay, so our student, aviation student, only have restored it back, that aircraft. Okay, so like that we have lot of parts available. We had lot of old aircrafts where now they are no longer used, but their propellers, engines, their parts, all things are being used into our workshop, because we also train our students for maintaining the aircraft. So we have a course for maintenance part also. Okay, aircraft maintenance course also is there. Aircraft maintenance engineering is also conducted by Bombay Flying Club. Okay, so we say made of wood, industrial or small grade or carbon fiber. So there are mostly the propellers what we use in a drone right now are either plastic grade, high quality plastic grade, or made of a carbon fiber. Okay, carbon fiber will be little bit more expensive compared to high grade plastic. Okay, any questions? Umesh, you have a question?
Sir, CW propeller show this number na, 1045R. त्याच्यावरून म्हणजे तो CW बोलतात त्याला.
नाही, number is different.
पर R कॉमन असतो ना, ते R लिहिलेला असतो त्याच्यावरती.
नाही. So that number and this thing is different. When you see, your propeller will always have CW or CCW written on it. ओके.
CCW वरती नंबर लिहिलेला असतो पण ते आर लिहिलेला नसतो त्याच्यावरती.
हाँ वो ठीक है, बट दैट इज अ डिफरेंट पर्पस. ओके, यू नीड
ओके.
टू फॉरगेट. समझो वो पॉपुलर पे कुछ लिखा ही नहीं होगा तो क्या करोगे आप? सो यू नीड टू आइडेंटिफाई योर पॉपुलर, राइट? सो वो लिखने वाला भी को मालूम होना चाहिए ना कि भाई ये CCW लिखना चाहिए या CW लिखना चाहिए. आप पॉपुलर के ऊपर लिख के तो नहीं आता ना, बाद में लिखा जाता है, राइट? तो व्हेन यू आर
हाँ,
मेकिंग पॉपुलर,
पर पर
व्हेन यू
उसका जो ड्रोन का जो 4 मोटर है वो किस मोशन में घूमने वाला है वो तो पता है, मतलब CW
तो कैसे
पहला
पता
मोटर.
चलेगा आपको? अगेन, हाउ
हाँ,
यू नो द मोटर विच विल बी मूविंग इन CW? क्योंकि आपको मोटर का डायरेक्शन भी पता होना चाहिए ना. अगर आपने CW का मोटर लगाया और उसके ऊपर CCW का प्रोपेलर लगाया तो दैट इज ऑल्सो रॉन्ग ना. So I don't park your point over here. I will explain you. I'll show you physically, which will
ओके.
you will never forget in your lifetime. Okay, I will
ओके.
make it sure that you understand what you are trying to, what I am trying to tell you, and what you supposed to know properly, so that you never forget in your life. Okay,
ओके.
so let's move ahead. Fuel system. Now, fuel system for BLDC motors is lithium-based batteries. So, LiPo or Leon batteries are widely used batteries. LiPo's batteries are custom built for different shape and sizes. Leon batteries are capable for higher endurance flights. So nowadays, mostly we are using lithium-ion batteries because of the costing as well as the endurance what we get with respect to the Leon. The energy density is far less compared to IC, that is internal combustion engines. Okay, because this will not give you that power. Okay, the endurance, as I said, using the battery system is hardly 20 minutes. My drone can fly only in a one battery charge for 20 minutes, 15 minutes max, 15 to 20 minutes, not more than that. Okay, so I need to have multiple batteries to fly. Whereas यहाँ पे मेरा एक ही टैंक है, एक टैंक में 20 लीटर्स फ्यूल डाल दिया, वो 8 घंटा उड़ाते रहो, उड़ता रहेगा आपका, राइट? So like I don't need to keep multiple tanks or anything. Next time मेरा aircraft land करेगा, just refill my tank. In 5 minutes I will refill the tank. Again I am flying. Whereas battery मेरा land करेगा, मेरे को battery 1 घंटा चार्ज करने के लिए लगेगा. So this is not that efficient. So this is where we are actually right now lacking in drone segment. The fuel system. अगर जिस दिन हमने fuel concept को overcome कर लिया, we'll have much better system. So this is basically a power, the energy required. So anywhere the fuels, like जैसे अपने कार में, like why we are able to drive car such a high speed and far location, because एक बार मैंने 70 लीटर्स का टैंक फुल कर दिया मेरा कार का, तो 500-600 किलोमीटर तक तो आराम से जाता है ना मेरा कार, राइट? कंपेयर टू बैटरी सिस्टम पे मेरा एक चार्ज में 300 किलोमीटर ही जाता है. वट एवर ईवी में कार यूज कर रहा हूँ, 300 या मैक्स 350 400 किलोमीटर तक जाता है. बट मेरा फ्यूल टैंक के हिसाब से आई कैन गो अप टू 600-700 किलोमीटर्स. तो यहाँ पे मेरा एफिशिएंसी बहुत ज़्यादा है. तो stored in a tank mounted on fuselage, the glow or nitro fuel, gasoline or diesel is used in these IC engines. Better thrust to weight ratios than lithium based batteries. तो यहाँ पे thrust हमको अच्छा मिलता है, better thrust. That's why you will see in internal combustion engines, okay, you will always used for a bigger fixed wing drones, okay, like this, okay, bigger drones. Similarly, there are alternative fuel system which are being getting tested. One is the hydrogen power and another is solar powered also. Okay, so these are two different new concepts have come up where people are testing the drones using this kind of fuel system. Okay, now, okay, as we are flying the drones, this is the one of the important part when we are flying the drone. So do you know what so I think Umesh, you must have used the RC, right? Even Brian, you would have used RC, the controls, right? And those people who are
Yes.
actually
Yes, sir.
all of you. So do you know what mode do we use of our RC? Are you aware there is something called mode?
Mode 2.
FSI-6.
Mode, not model I'm talking about. Mode. There are mode.
Yes, sir.
Are you aware of
Aileron.
the modes?
Mode
Aileron.
2.
Who said mode 2?
Elevator.
I said, sir, Abhik. Mode
Abhi.
2.
Yeah. So do you know what is mode 2?
Yes.
Yeah. Can you tell me?
Mode 2 basically has the throttle on the left stick, throttle and yaw on the left stick, and pitch and roll on the right stick.
Very good. Very good. That's the right. So normally, whatever the RC we are flying, okay, the remote control we are using are already configured in mode 2 functionality. What is mode 2? Mode 2 is nothing but what is our organization short form? RPTO, right? Remote
Yes.
Pilot Training Organization.
Organization.
Okay, so here also we need to see RPTY. Only O is replaced by Y. Okay, so RPTY. So on your right side, you have roll and pitch. On your right side, you have roll and pitch. On your left side, you have throttle and yaw. Okay, so this is called as mode 2 configuration. So all of I mean, Asians, even some person in Europe and a lot of places, except I think some location, maybe Australia or Canada, some location where people use mode 1. Mode 1 is exactly opposite of mode 2. So your roll and pitch is on your left side, and your throttle and yaw is on your right side. Okay, so when we are using the joystick on our remote control, our right side stick is always throttle, roll and pitch, whereas on your left side stick is your throttle and yaw. Okay, so these are our basic. So roll means what? Move your drone left or right in air, literally rolling. मैंने बोला था ना rolling. Rolling is like this, rolling, rolling. Okay, roll कर रहे हो आप. Pitch means tilt forward or backward.
Backward.
I am giving a pitch forward, pitch backward. So मेरा drone आगे जाएगा या पीछे जाएगा. Throttle means to move your drone upward or downward. So altitude change होगा आपका, right? Whereas yaw means rotate your drone clockwise or counterclockwise, allowing you to make circle or pattern in air. So yaw आप क्या करते हो? आप heading change करते हो. आप heading change होता है. आप बोला ना मैंने 90 degree yaw करो. Yaw right 90 degree. So when I say yaw means you moving your heading of your drone in a right side by 90 degree. Okay.
Forward direction change होते हैं.
हाँ, heading change होता है. Heading.
हाँ हाँ
Forward
ठीक
heading
सर.
change होगा आपका.
सर तेज बोल रहा हूँ.
हाँ, ठीक है.
हाँ.
So this is what I was talking about, control system, radio controller. So your channel 1 is your roll, channel 2 is your pitch, channel 3 is throttle, channel 4 is yaw. Okay, so this is your mode 2 configuration. Okay, यही ऐसे टाइप का कंट्रोलर रहेगा आपका. Okay, this controller is basically used for simulator trainings. Okay, whereas there would be a different type of controller, much advanced type of controller, which we'll be using when we are flying actual drones. Any idea what would be the cost of this controller?
Between 1.5 to 2, I suppose.
What is 1.5 lakhs you are saying or
Yeah, lakhs.
no? No.
5,000.
12 to 15,000. This is
Okay, so
Taranis.
this controller, this might Taranis, so it might be a little bit more expensive, but the normal basic radio controller starts with 5,000 rupees, and it can go up to higher end. Whereas the controller what we are using for our enterprise class drones, Brian, what you said is correct. It is 1.2 lakhs. Okay, 1,20,000 rupees. So they are expensive because they have a LCD where they are feeding your everything, all sort of information on that. So it is a full-fledged remote control. Okay, through that you can completely do autonomous flying and all sorts of things with that drone, with that remote control. Okay, so the higher features, more features you have, the expensive it will become. Whereas these are very simple flight controllers which are used for basically for aero modeling and basic flying kind of thing. So we use this kind of control basically for simulator training. Okay, then like as I said, a lot of time we have a third category, subcategory called autonomous. So you can always have some software called ground control station on your laptop, or there are dedicated ground control stations also available where there would be a software which is known as mission planning. Anybody of you have used mission planning software?
Programming software.
Not programming, basically it is for autonomous configuration. You can program or you can define your flight plan. Okay, you can plan your how your drone is going to fly or your aeroplane is going to fly, or your hybrid control also can. So even for copter or rovers also it can be. So it is basically a software which can give inputs or define the path for its motion, either it is in air, either on the land, or even underwater also. Okay, so this software can be used for defining your movements, okay, or paths, as well as defining your uh, what we say the mission plan. This is as of now only available for Windows. Okay, mission planner can be used for configuration utility, as even you can do lot of customization, you can do lot of fine tuning of your device so that it can give you optimal result in flying. फॉर एग्जाम्पल जैसे अभी मेरे को ड्रोन फ्लाई करना है इन एग्रीकल्चर फील्ड, so I will not fly my drone manually because that is I'm not so efficiently flying my drone, I'm not so expert in flying drones. तो what I will do is, because क्या होगा, मैं मैन्युअली फ्लाई करूंगा तो मैं सीधा फ्लाई करूंगा, फिर राइट लूंगा, फिर वापस और एक राइट लूंगा, देन आई विल कम बैक, then I will take left, right, all that things, but that human intervention what is required over there will actually consume more power, consume and delay things over there. But if I have a mission planner defined, a plan which is defined where I can define the motion of my drone, so the drone will able to fly very efficiently, very smoothly, and will consume less power. So एक charging cycle of my battery I will should able to complete 1 acre of land of spraying. अगर मैं वो मैन्युअली करने जाऊं ना तो मैं आधा भी नहीं कंप्लीट कर पाऊंगा, एंड इट विल नॉट बी यूनिफॉर्म ऑल्सो, बिकॉज आप जब एग्रीकल्चर फील्ड में आप फ्लाई कर रहे हो ड्रोन को, योर फील्ड इज व्हाट यू कॉल इट इज अ प्रॉपरली प्लान्ड फील्ड, राइट? प्रॉपर उसके पाथ रहेंगे, बीच में गैप रहेगा, वापस पाथ रहेंगे, फिर वापस गैप रहेगा, ऑल दैट काइंड ऑफ थिंग्स। सो यू नीड टू एक्चुअली प्रॉपरली फ्लाई एज पर योर फील्ड। तो फील्ड के हिसाब से मुझे फ्लाई करना, जो मैन्युअली पॉसिबल नहीं है। तो इन दैट सिनेरियो, सो ये नॉर्मली हम लोग जब एग्रीकल्चर कोर्स कराते हैं स्टूडेंट्स को, व्हेन वी टीच स्टूडेंट agriculture, so there is a team which comes from our OEM, there is a trainer who comes from the OEM who actually teaches the farmers, lot of farmers who come to our place for learning flying for agriculture drone, okay, for agriculture spraying कैसे करना है या spraying कैसे drone को configure करना है, all that. So in that course that instructor basically trains the students for that kind of planning. So वहाँ पे आप fly नहीं कर रहे हो drone, आप क्या कर रहे हो, आप रेडी कर रहे हो ड्रोन को, बैटरी लगा रहे हो, सब कुछ कर रहे हो, और आपका कंट्रोल में आप प्लान बना के ड्रोन को एग्जीक्यूट कर रहे हो, वो प्लान को एग्जीक्यूट कर रहे हो। यू आर एग्जीक्यूटिंग द प्लान व्हाट इज बीन फेड इनटू द रिमोट कंट्रोल, एंड देन based on the plan which is fed into the remote control, that plan is been uploaded to the drone, and then drone takes on its own. That is called as autonomous flying or mission flying, mission planning flying. Okay, so this is how it will be look. So like lot of time सर्वेइंग के टाइम पे भी हम लोग करते हैं मिशन प्लानिंग, या फिर नेचुरल डिजास्टर के टाइम पे अगर मुझे कुछ सर्वे करके प्रॉपर फोटोज लेने हैं, कैप्चर करना है, डेटा कैप्चर करना है, सो इन दैट सिनेरियो आई विल ऑलवेज फ्लाई द ड्रोन इन मिशन प्लानिंग सॉफ्टवेयर. Okay, so you will have, you start your drone from here, it will go, see it is very uniform and structured way of capturing, you will not miss anything, and then it will come back to its launch position. Okay, and then you can take down and you can collect the data, either it can be download the data through the cloud, or you can take the chip from the drone and put it back into your laptop, and then you can transfer the data for your further analysis. Yes Umesh.
सर हे ऍग्रिकल्चर ड्रोनचे ट्रान्समीटर वेगळे असतात ना?
वेगळे असतात म्हणजे
जसं म्हणजे हाय रेंज वाले.
हाँ, तो that's what I said ना, my drone is having a remote controller which is almost costing me 1.2, because I am using H16, H12 kind of controllers for my flying drones. So we are actually going to use those kind of remote controls when we are flying our drones. उसमें उसका खुद का सॉफ्टवेयर भी रहेगा, तो विल बी लर्निंग लॉट ऑफ लाइक हमारा लैंडिंग जो पैटर्न्स है, हम लोग लैंडिंग है वो RTL यूज करके लैंडिंग करते हैं, क्योंकि हमारा जो ग्राउंड है वो थोड़ा प्लेन नहीं है. ओके, थोड़े से वहाँ पे मतलब वी हैव सम चैलेंजेस ओवर देयर एज ऑफ नाउ. वो ग्राउंड एकदम प्लेन नहीं है, तो हम लोग को श्योर नहीं है कि लैंडिंग के टाइम प्रॉपर लैंड होगा कि नहीं होगा, नहीं तो कभी
Okay.
हमारा ड्रोन टॉपल हो सकता है, उल्टा हो सकता है एंड डैमेज हो सकता है। तो नॉर्मली हम लोग लैंडिंग के लिए उसका फीचर यूज करते हैं, रिमोट कंट्रोल का, RTL, ओके, रिमोट
अम,
टू लॉन्च, रिटर्न।
मग मग सर हे जे ऍग्रिकल्चर ड्रोनचे ट्रान्समीटर आहेत त्याच्यामध्ये फक्त ते जसं ती मॅपिंग केले जसं हे पिक्चर मध्ये दाखवलं ते त्याच ट्रान्समीटर मध्ये होते ना?
हाँ हाँ,
ओके.
उसी के अंदर होगा, वो सब होता है। वही मैं कह रहा था कि आई वॉज टेलिंग दैट ओनली दैट ड्यूरिंग आवर एग्रीकल्चर कोर्स का जब ट्रेनिंग होता है फार्मर्स के लिए, तभी ये कोर्स में ये सिखाया जाता है, क्योंकि उसमें आप ड्रोन कैसे फ्लाई करना है वो सीखना नहीं, आपको ड्रोन को कैसे कॉन्फ़िगर करना है और कैसे इनपुट्स देना है, कैसे ये प्लान बनाना है, वो सिखाया जाता है। देयर यू आर नॉट लर्निंग, बिकॉज दे आर ऑलरेडी डन द कोर्स, दे ऑलरेडी पायलट कोर्स किया हुआ रहता है उन्होंने, उनको ड्रोन फ्लाइंग आते रहता है। नाउ द नेक्स्ट स्टेप इज टू लर्न फॉर दिस काइंड ऑफ एक्टिविटीज। तो अगर आप सर्वेलेंस में कर रहे हो तो सर्वेलेंस का कोर्स अलग होता है, आपका एरियल फोटोग्राफी है तो एरियल फोटोग्राफी का अलग होता है, पावर लाइन ट्रांसमिशन के लिए कर रहे हो तो पावर लाइन ट्रांसमिशन का कोर्स अलग होता है, आप अगर एग्रीकल्चर के लिए फ्लाइंग कर रहे हो तो एग्रीकल्चर के लिए ड्रोन का कोर्स अलग रहता है। तो डिपेंडिंग अपॉन द एप्लीकेशन, समझ लगे नहीं, so what application you are going to use for your drone, that type of the course has been designed and been taught to it.
आणि सर हे जे ऍग्रिकल्चर ड्रोनचे ट्रान्समीटर आहेत ते म्हणजे किती चॅनलचे असतात? जसं नॉर्मली
16 channel, 12 channel, 14 channel, 16 channel.
ओके.
Channel से कुछ नहीं, channel is just a controls. Your first 4 channels are your primary channels which controls, remaining channels are nothing but they are extra controls. जैसे अभी मेरे को उसका एग्रीकल्चर ड्रोन का मेरे को मोटर पंप है, उसको ऑफ करना है, ऑन करना है, उसके प्रेशर स्लो कम ज्यादा करना है, तो वो सब कंट्रोल्स उसमें आते हैं। तो जो एडिशनल स्विचेस जो है वो उसके लिए कंट्रोल्स,
ओके.
जैसे फॉर एग्जांपल अभी आप एरोप्लेन फ्लाई कर रहे हो, राइट, आप
हाँ.
4 कंट्रोल से तो आप रडर, एलिवेटर, एरोलॉन सब कंट्रॉल कर रहे हो, बट आपको
हाँ.
लैंडिंग के टाइम पे आपका लैंडिंग गियर नीचे आना चाहिए, तो आप कैसे कंट्रोल करते हो? तो एक स्विच रहता है, जो स्विच आप टॉगल करते हो तो आपका क्या होता है, दरवाजे खुल जाते हैं और वो
हाँ.
लैंडिंग नीचे आता है।
ऑक्सिलरी स्विच.
Auxiliary switch, any switch whatever you are want to, you can configure any of the other switches apart from the first 4, okay. So
Yes.
depending upon the function, जैसे फॉर एग्जांपल हमने फैंटम ड्रोन है, मेरे को फैंटम ड्रोन के नीचे एक बॉक्स लगाना है, उसमें फ्लावर्स डालने हैं और उस पे मैं एक सर्वो मोटर लगा रहा हूँ, और वो सर्वो मोटर को मैं जब स्विच से अपने रिमोट कंट्रोल के स्विच से कंट्रोल करूंगा तो वो सर्वो मोटर एक्टिव होना चाहिए और वो डोर खुलना चाहिए और फ्लावर्स नीचे गिरने चाहिए। तो ये कॉन्फ़िगर करना है, तो मैं एक स्विच को वो फंक्शन कॉन्फ़िगर करके लूंगा, and that
Yes.
function will be operated through my RC, through my
ओके.
transmitter and receiver,
ओके.
correct?
येस.
So let's move. So takeoff for the fixed wing is like either handheld, मतलब हाथ में पकड़ के मैं उसको हवा में फेंकता हूँ, या फिर there could be a catapult mechanism, there is a rail which is there, spring loaded रहता है और उसको हाई प्रेशर से एयर में फेंकता है। थर्ड ऑप्शन इज रनवे टेक ऑफ और लैंडिंग, सो देन यू नीड अ रनवे फॉर सच काइंड ऑफ ड्रोन्स, whereas the landing or the recovery for the runway is normally वो वापस वो रनवे पे आके लैंड करेगा, बट देयर आर अदर ऑप्शंस लाइक पैराशूट रिकवरी भी है और नेट रिकवरी भी है, या फिर जिपलाइन रिकवरी भी है। Okay, so clear on the takeoff and landing part. Any questions so far?
सर हा दुसरा नंबरचा इमेज आहे त्याला कॅटापुलर
Catapult.
हे एअरक्राफ्ट कॅरियर वरती पण असंच हे करतात.
हाँ, बट वो एयरक्राफ्ट कैरियर पे कैटापुल्ट नहीं होता है, वो एक्चुअली उसको रिकवरी मैकेनिज्म बोलते हैं, उसको कैटापुल्ट नहीं यूज करते। वहाँ पे जो एयरक्राफ्ट कैरियर पे आपका क्या होता है, वो आपका जो एयरक्राफ्ट रहता है वो तो अपने मोशन से फ्लाई करता है, बट जब वो लैंडिंग करता है ना तो उसको पकड़ना पड़ता है।
ओके, हाँ।
ओके, तो उसमें एक 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 रस्सी लगी हुई, स्प्रिंग लोडेड रस्सी रहती है, वायर रहता है जो एक्चुअली उसमें हुक में अटक जाता है और जिससे वो
हाँ,
आपका एयरक्राफ्ट होल्ड करता है.
ओके।
Okay? So applications like surveillance, agriculture, mapping, wildlife protection, construction, mining. So you normally see the fixed wing is been used for covering the larger part of area. Okay, अगर आपको बहुत बड़ा एरिया कवर करना है तो normally you will use fixed wing. So understand where the fixed wing will be used. Okay. So let's see the comparison between the fixed wing and the multi-rotor. So fixed wing unable to maintain the fixed. ये सबसे बड़ा पहला drawback है. क्या है? Unable to maintain the fixed position because it's always the fixed wing is always in a forward motion. Can only fly horizontally forward. वो vertically ऊपर भी नहीं जा सकता है, right? वो एंगल से ऊपर जा सकता है, बट एकदम से ऊपर नहीं जा सकता है. वो जेट इंजिन वो सब जाते हैं, वो अलग बात है बिकॉज दे हैव अ डिफरेंट पावर मैकेनिज्म ओवर देयर. ओके, जो फाइटर प्लेन्स रहते हैं वो जो एकदम वर्टिकली सीधा ऊपर जाता है, वर्टिकली नीचे आता है, क्योंकि वहां पे सिविल एयरलाइंस नहीं, सिविलियंस नहीं है वहां पे, सिर्फ एक एक या दो फाइटर पायलट्स ही रहते हैं. ओके, सो दैट काइंड ऑफ प्लेन एंड द काइंड ऑफ द प्लेन इज इट रिक्वायर्ड दैट काइंड ऑफ मैनोरेबिलिटीज. ओके,
एग्जाम्पल फॉर F-22 रैप्टर.
हाँ, तो वो तो मिलिट्री का है ना, तो वहां पे आपको वो उसमें वैसे मोशंस होने चाहिए बिकॉज दैट इज द फास्ट मोशन होना चाहिए, बिकॉज वो आप वॉर के लिए यूज कर रहे हो. वेयर आपका नॉर्मल फिक्स्ड विंग जो होता है एरोप्लेन या सिविलियन एयरप्लेन्स, देयर यू कांट हैव वर्टिकल मोशंस ऑन दैट. ओके, देन
यस.
टू लॉन्च द फिक्स्ड विंग यू रिक्वायर्ड हैंड और मैकेनिकल लॉन्च. यानी कि ये फिक्स्ड विंग एरोप्लेन आपको लॉन्च करने के लिए इधर आपको हाथ से फेंकना पड़ता है. अगर छोटा है तो आप हाथ से फेंक सकते हो, लेकिन अगर प्रेडेटर जैसा ड्रोन है तो आप उसको हाथ से फेंक नहीं सकते हो, आप मैकेनिकली लॉन्च नहीं कर सकते हो, राइट? उसके लिए आपको रनवे ही लगेगा. But advantage of fixed wing is longer average flight times. We have seen this, right? Can carry heavier payloads. Great stability in the wind. Why does it has a great stability in the wind? Any idea?
काय
Wind.
सर, परत सांगा.
लास्ट वाला ये फिक्स्ड विंग में why there is a great stability in the wind?
नाही समजलं सर प्रश्न.
मैं ही पूछ रहा हूँ, फिक्स्ड विंग ड्रोन जो है इट हैज अ ग्रेटर स्टेबिलिटी इन द विंड. क्यों ग्रेटर स्टेबिलिटी है? जबकि आप मल्टी रोटर में देखो क्या लिखा है, लेस स्टेबिलिटी इन द विंड. व्हाई दिस डिफरेंस इज देयर इन बिटवीन दीस टू टाइप्स ऑफ ड्रोन्स?
Maybe because of the airfoil.
Design, the aerodynamics design. Your multi rotor drones are never designed aerodynamically. Okay, whereas your fixed wing are always designed aerodynamically. That's why they have a greater stability in the wind. फॉर एग्जाम्पल, अगर विंड बहुत सारा फ्लाई हो रहा है, स्टिल इट कैन काउंटर, इट कैन कंट्रोल द फ्लो ऑफ द विंड. Whereas my multi-rotor will never able to control. How it will control? By moving the motors or rotors. Okay, so it is consuming my power. Whereas fixed wing doesn't need to consume any power. It will try to align its shape. Okay, it will control. अगर उसके ऊपर wind का pressure आ रहा है, तो it will control the flow of the air. Right, that's why it has greater stability in the wind because of the design. So your fixed wing aeroplanes or UAVs are always designed aerodynamically, whereas multi rotors are never designed aerodynamically because they cannot be designed. Okay, because of the functionality and the shape of it. Okay, जैसे अगर आप देखोगे, see you can assume or you can design them a bit aerodynamically, but not 100%. जैसे फॉर एग्जाम्पल अगर आप मैविक देखो या कोई भी अदर ड्रोन देखो कंपेयर टू DJI फैंटम. नाउ फैंटम का शेप देखो, थोड़ा एरोडायनामिकली डिजाइंड है. द कर्वेचर, द शेप ऑफ द फैंटम, उसका शेप पूरा मतलब एयरफॉइल जैसा, उसका बॉडी, उसके जो आर्म्स जो है, दे आर ऑल एरोडायनामिकली डिजाइंड. सो देयर DJI has tried their best to design that drone aerodynamically, but they are not 100% aerodynamically designed. थोड़ा सा रहेगा उसमें, ड्रैग रहेगा. Okay, there will be a drag. Okay, so if you see higher, generally higher flight speed, since it is a fixed wing, it can fly at a very high speeds, whereas multi-rotor are easy to control and maneuver, have ability to hover. This is the most important benefit of the multi-rotor or drone. Okay, can take off and land vertically. This is another positive of the multi-rotor drone. So you don't require a long strip to fly or land the drone. Here you can vertically take off and vertically land. Limited flying time. This is the drawback now because of the BLDC motors utilizing batteries, lithium ion batteries or lipo batteries, whatever you are using. So they will always have a limited flying time. It could be 15 minutes, 20 minutes, 30 minutes, 40 minutes, depending upon. Okay, small payload capacity. Because of the size, it will always have a small payload. Like if you see a wing, fixed wing, they are very big in shape, they can carry heavier payloads, they have a higher endurance capacity, all that things. But multi rotors, you can't make very big multi rotors also. Okay, they will always have power to weight ratio, will be always have a big challenge over it. Less stability in the wind because they are not aerodynamically designed. And as well, since they are just using BLDC motors, they will not have a very high speed, lower flight speeds compared to fixed wing. So comparing to the fixed wing, multi-rotor will be always have a lower speeds. Clear on the comparison part? Any questions, any doubt you have?
No.
Okay, so with this, we complete the topic on the fixed wing operations and aerodynamics. So let's go to now next topic. We are already running behind our schedule. We will complete the next presentation on rotorcraft. Let me know once you see the screen.